to be very fast. Now you can create SQLite databases in memory that you're not saving any data permanently, it's just kind of used for scratch space, or more commonly you can manifest your database as a file in the file system. You know, you're probably using SQLite databases every day and you don't even know about it. Mozilla Firefox, Mozilla Thunderbird, the Adobe Air desktop application environment, Palm's WebOS, the iPhone OS, the list goes on and on. SQLite is pretty ubiquitous nowadays, and you can download and install a distribution of SQLite for any operating system, and there's tons of management add-ons for this free and open source product. Wikipedia has a good article on D. Richard Hipp. He's the computer scientist who is the primary author of SQLite. And by the way, he does pronounce this product SQLite and not SQLite, as some folks pronounce it. The homepage for SQLite is sqlite.org. Very simple, elegant page. However, for our purposes in Python, we actually do not need to worry. I repeat, we do not need to worry about downloading and installing SQLite. The reason for that is that recent versions of Python, certainly 3 included, bundles SQLite with the CPython distribution available at python.org. Now, whether other distributions include SQLite, I will defer to those particular project home pages, but CPython does give you SQLite. Now, in the wild and in the literature, you're going to see references to PySQLite and SQLite 3. These are the same thing. They both refer to the SQLite database. PySQLite is the name of the project that's developed externally of CPython, of course. The module that comes standard with Python 3 is SQLite 3. This is a standard library module. You certainly remember PyDoc, right, from earlier in our lesson. You can look up SQLite here and take a look at the page in a web browser and read all about its included functions. There's connect, we're going to be using that very shortly, and so on. Speaking of connection, using SQLite in Python is remarkably easy, as you're going to see in the upcoming demo. The first object you create is called a connection object. This is a handle to a particular database, and it functions a little bit like the read function does with files, in as much as you use a connection object to open a handle to an existing database, or you can create a new one on the fly. The databases are binary files that exist in your file system. You can give them any extension you want. You can give them no extension. I've seen SDB given. I've seen .db given. It's really administrator preference there. You can also create a connection object using the memory flag, :memory:. This generates a non-persistent in-memory database that's useful for testing, but of course that data is volatile, and after you close your session, all of that goes away. After you have your connection object up and running, the next thing you'll do is create a cursor object. Now, this isn't exactly the kind of cursor that you're used to working with, say, in MySQL, Oracle, or Microsoft SQL Server. In Python SQLite, a cursor object acts as a handle for particular database objects. So once we're in a database, we can create and edit tables, we can do inserts, updates, deletes, we can certainly run select statements. Speaking of those aforementioned structured query language statements, the execute method is used in conjunction with your cursor object to execute SQL. Now, depending upon your previous experience with RDBMS systems, there's always the question, how faithful is a certain platform to the ANSI ISO SQL92 standard, which is pretty much the benchmark standard. There's been a couple since then, but this is pretty much the benchmark for defining standards compliant SQL. And the bottom line is SQLite is very faithful to SQL92. There are some minor departures, but then again, you know what? Microsoft with its Transact SQL, tons of departures from SQL92. Oracle, MySQL, they all these different platforms have their own implementations of ANSI ISO SQL, so it's really not a big deal. Anything you know about standard SQL data definition language statements like create, alter, and drop, and data manipulation language statements like select, insert, update, and delete will work just fine. So enough of me flapping my gums. Let me show you how this actually works in practice. Alright, in this demonstration we're going to work with database access to SQLite in Python 3. First I'm going to import the necessary modules. Now really we just need the one, the SQLite module, but I'm going to import OS in addition to SQLite 3, and that's simply so we can invoke the getCurrentWorkingDirectory and verify where we are in the file system on the host computer. The reason for this is very simply that when we open up a connection and create a new database in SQLite, it's going to create that database file in your current working directory. So you'll want to also make use of the changedir function if you need to flip over to another location in the file system. But for now we're fine in the Python 31 directory. I'm going to create a connection object here by calling the connect method of the SQL3 library. And here's where we specify a path to an existing database, or if we want to create a new one, which we do right now, you can specify that value as a string. Remember, an extension is optional. I'm not going to use an extension for mine because I'm only going to be accessing this database from within Python. This is a binary file, as I've stated before, so you don't want to try cracking it open in Notepad or HexEdit or any tool like that. You might wind up corrupting the database. If we run type on this connection object, it tells us that we've created an instance of the class SQLite3.connection and therefore inherited all of the properties, attributes, methods, etc. inherent in that base class. Next thing we want to do is create a cursor, which remember is a handle to that database. So this is going to be a call to the cursor method of our new instance, con.cursor. At this point we've created a new database. If I bring up Windows Explorer for just a minute, you'll see we have a file called HRDB. It's empty, it's 0 KB. We haven't added any data to it, of course. We're about ready to do that. Now I'm skipping over a ton of architectural stuff. What is the purpose of this database? How are we going to create the schemas or tables? And how are we planning on linking those? We can do joins, we can do one-to-many relations, one-to-one to relations. All your traditional relational database stuff is available to us here in SQLite 3 library. So be aware of that. In this one, we're just going to create a simple table, do a couple row inserts, and then I'll show how to run select statements against it. Good and good. Now, to do some actions on our database, what we want to do is use the execute method. Execute is really an all-purpose kitchen sink method that we run as an attribute of our cursor, as you see here. And boy, we can do DDL, create, alter, delete, we can do DML, we can do it all with execute. Tip I'd like to give you is to use the triple quoted string format to give yourself some breathing room. Otherwise, you're going to have to use the escape character to do a multi-line. That's